Hello everyone, welcome to another episode of the Stellar tutorial series. In this episode, I'm going to be talking about stellar data structures. In previous episodes, I talked about the stellar consensus protocol. So we talked about what we mean by the protocol, the agreement between nodes on the stellar network, and then I also talked about the proof of agreement consensus mechanism used by stellar network and how it differs from the proof of work and the proof of stake that chains like Bitcoin and Ethereum uses. And then we went ahead there and I discussed about the quorum set and with respect to the proof of work consensus mechanism, talking about the quorum set and how it works with visual diagrams, and also talked about thresholds and quorum slices and how all of these things interact with each other, how they make up the consensus mechanism and how they work. And then also, so we talked about all of those things in the previous episodes, talking about the consensus protocol. So that's basically what we talked about. So if you're interested in that, you can go check it out in the previous videos. So in this video, I'm going to be talking about the stellar data structure. So basically, what are these data structures we are referring to? They are the building blocks, right, that are present on the stellar network. So these are things you, as a user, always interact with, always make use of on the stellar network. So they are what enables you to be able to do certain things on the network, like perform actions, interact with contracts, perform transactions on the network. So we are going to be looking at the four of them that's fundamental to this tutorial series. And so we have these four. The first one is the ledger, and the second one is accounts, the third one is assets, and the fourth one is smart contracts. And over the course of this video series, we will have mentioned, I'm sure I've mentioned either of these four. Like I know I've mentioned, we talked about accounts when we talked about accounts when we discussed Lumen, talking about the base reserve. We're talking about lumens with respect to accounts also. And we also mentioned assets as well. And smart contracts, we just talked about it. We didn't go deep. So in this video, I'm going to be talking about them in detail and trying to explain all of these concepts as much as possible. So the first thing to understand about this is the ledger. Now let's go to what a ledger is. Now the first thing to know is that a ledger, like remember from the concept of the blockchain, that the blockchain is basically a decentralized ledger, right? It's a distributed ledger and it's a decentralized and secure ledger. So let's look at it from the concept of this. So when you look at ledgers, the first thing you tend to understand is that a ledger is basically the state of the blockchain at the point in time. But in Stellar, that is what exactly it is. But in other blockchains, you might refer to ledgers as Stellar makes use of it here as blocks, right? So we know that is a distributed ledger. Now, in Stellar network, ledgers represent the state of the network at the point in time. They are shared across all the core nodes in the network, just as we have it here. And they contain the list of accounts and balances, orders on the distributed exchange, smart contract data, and any other persistent data. So, but the way to understand it is this is a ledger. Let's assume this is a ledger, this is a ledger, this is a ledger. They are all linked, right? So they are just like blocks. If you're familiar with other blockchains like Bitcoin, Ethereum, the ledger in Stellar is basically a block in those blockchains, right? So you look at them that they are linked together. They are cryptographically linked to the previous ledger. So a child ledger is linked to its parent ledger, and that creates a chain. And so we have something called the Genesis block. So I could list this and say that, okay, so between these blockchains, A, B, C, we have a Genesis block that they are linked to. So just say this is blockchain A, blockchain B, let's see, blockchain A, blockchain B, sorry, block A, block B, and block C. So we have this as ledger A, ledger B, and ledger C in Stellar. Then this becomes the Genesis block or Genesis ledger. Stellar. So if you understand that from coming from a concept of blockchain, then that is basically what it means. But if you do not have any pre-knowledge about blockchain, so what you need to understand is that it's basically a ledger, right? In this case, so it's a ledger. It is where you store data. Any ledger, any data that you need that is being interacted with, that is being stored on the chain, they are stored within this ledger. So the data are stored on the ledger, right? And every data you store on the ledger are referred to as a ledger entries. So that's basically what it is. So what do you have stored on the ledger? You can have things like accounts, right? You can have things like accounts. You can have things like contract data. They are basically stored in the ledgers. You can have liquidity pools, claimable assets. All of these things are stored on the ledger. So better way to look at it is that they are just those entries, right? You have entries on the blockchain. The blockchain is a distributed ledger. It's a decentralized, distributed, and secure ledger. So that way you have this as blockchains, as blocks, right? You have them as ledgers on the blockchain. So basically, this is like a general overview of what ledgers is. So you can look at them as blocks of data, right? And in this case, they represent the state of the blockchain, right? They don't control, but they represent the state of the blockchain. And then what you store data in these ledgers, you store data such as your account, right? Remember that you need to have an account on Stellar with a minimum balance. Those accounts you own are stored in ledgers. The claimable assets are stored in ledger. The pools, liquidity pools are stored in ledger. We'll still look at all this eventually. The contracts data, because you need to deploy contracts, you need to have data stored, contracts stored on chain. The data of those contracts in terms of bytecodes or whatever are also stored on ledgers. So they are like storage points that we have on the blockchain. And so they represent the state of the blockchain at any point in time, meaning that whatever happens here and happens here means there's a state change. And whatever happens in blockchain C or ledger C also means there's a state change. I'll call this ledger C. I'll call this ledger B. And this we refer to as ledger A. So we could have them like this, and this makes a lot of sense, right? So that's basically what ledgers are with respect to Stellar. Now let's look at the second one, which is accounts, right? So looking at accounts, so what are accounts? Now we've mentioned accounts before when we talked about Lumen in the series about Lumen. If you've been following the series from the beginning, we spoke about accounts in that series. I didn't want to talk about it, but then I just had to chip in a lot of things because we're already talking about it. So in this place, this series was supposed to be for accounts and it's still for accounts. So we're talking more about accounts in this place. And so what are accounts, right? So account in Stellar is the central data structure. I think this is very important to know. It's this central data structure in the Stellar network. And because everything you do on the Stellar network, you do with accounts, right? And that's why when you look at the properties of accounts, the first thing you see is that they hold balances. If you remember from the series, the video about lumens, we said account needs to have a minimum balance. Every account, even from the first video, we said every account on Stellar needs to hold minimum balance. It's a requirement that must be met by every account. So properties of accounts on the Stellar network, like we said, they are central to Stellar network. They are central data structures. So properties of those accounts are the hold balances, the signed transactions, and the issue assets. Now, what do we mean by signed transactions? Because they exist as a key pair, right? So accounts are basically generated using key pairs, private keys and public keys. So they sign transaction, and signing that transaction requires you to use your private key to sign, more like you're having a digital signature of, yes, I want to perform this action. This is my signature to verify that I'm the one initiating this transaction, right? It's basically like you going to a bank and wanting to issue a particular action there. Probably you want to sign a check, or you want to validate, or you want to issue a check, right? You need to have your signature on that to verify that, yes, you own this. So it's basically the same thing in this case. You are signing a transaction, meaning that you are using your digital footprint, your digital identity, right? Your signature. So it's a digital signature that you use to initiate, and you need to confirm and tell the blockchain that, yes, I'm the one initiating this transaction. So we sign transactions using accounts, right? We hold balances, accounts hold balances, and accounts are also used to issue assets, right? Because they're like the entry point to doing all of these things. So then you can also see that, yes, we talked about key pair already. So accounts can exist as a key pair, and it must have a minimum balance of, we spoke about that, 1 XLM. Must have a minimum balance of 1 XLM. So we talked about components. So now let's talk about component of account, right? So accounts, because they are central to the Stellar network, they have certain components. And if you look at this component, you see that, yeah, they are really central to the data. They are really central data structures to the Stellar network. And now let's look at the accounts. So the accounts in this case are the account ID. Account ID, basically, you can look at them as your public key, because like what I explained the other time, we have the private key and the public key, right, existing as a key pair. So you can look at your account ID as your public key, right? You can look at it as that ID, the key or that number. It's basically a number, right? It's the public key that you use to generate your account. So the flow of this account ID is this: you have a private key, right, that you use to generate a public key. So let me try to draw this out. So you have a private key. Let me use the flow. So you have a private key somewhere. Let's say this is your private key. Then you have a public key. Let me duplicate this. So your private key generates your public key. So using the arrow basically means that this generates this. This generates this. And then from here, the public key then generates your address. So, and so whatever that address that has been generated, you could say that is your account ID. So in this case, it's basically this flow. You have your private key generating your public key, then your public key generating your address. Or you could call it your account ID. Yes. So you can look at this, look at it in this way, right? So the account ID in this case now is the public key that is used. So yeah, let me not call this the account ID. So this is the account ID in this case. So it's the public key in this case. Is the account ID that is used to generate your address. So this is like a typical blockchain flow of private keys to public keys to addresses. So now in Stellar, the account ID is the public key that you use to create an account, right? It's used to create an account. So the account ID is basically that public key that is used to create an account. So that's the flow. So then looking at, let's continue with the next one, looking at balances. So balances are basically the amounts that you have within the account, right? So basically that's what it is. So the amount, the amount that you have, the number of assets that you have, the balance of those assets that you have in an account are balances. So flags are just basically flags. They are like basically what they are. They're like flags that are used to check, they used to turn on and turn off certain things that you can perform on an account, right? So it's more like a switch. You can look at it like a switch to turn on and turn off if this is possible or not possible. Then we'll talk about the home domain. It's more like the domain. It is the domain of an account. Now we'll look at all of this in details in other videos because they are like they exist as their own information, and probably we need to talk about them later on, but that will come in a later video. And home domain are basically domain for an account. And then we have liabilities also. Not like the same way you have assets and you have balances of assets, you have liabilities that are attached to accounts. Like I said, we'll come to this in subsequent videos and we'll talk about them in detail. Accounts basically. So so we've spoken about, look, now moving on from the component of account, we understand that these are some of the components, some of them, these are not all, but we still have other ones. We have about 5, 6 more of them. So we total to about 11, 12 components that exist in Stellar. So looking at them from this perspective, so let's look at the next thing, right? So we have the base reserve and the sub entries. So we talked about base reserve when we spoke about lumens, right? If you could remember, we said the base reserve is a unit of measurement. And the reason why we are using the base reserve is to calculate an account's minimum balance. I'm saying we say that one base reserve is 0.5 XLM, but an account must have 2 base reserve equals to 1 XLM, right? So 2 base reserve equals to 1 XLM. 1 base reserve is 0.5 XLM. So that's basically what base reserve is. It's still the same thing as what we discussed previously prior to this video when we discussed the lumens, right? So it's basically the same flow. We already did a bit of like introduction to accounts there, but more than an introduction, and this is just the same thing from there. But in order to look at it this way, so a base reserve is a unit of measurement that you use to calculate an account minimum balance. And 1 base reserve is 0.5 XLM, and an account must have a minimum of 2 base reserve. And so that is why up here we said accounts can exist as a key pair and must have a minimum balance of 1 XLM, meaning that it must have an account must have a balance minimum of 2 base reserve, which is still the same thing as saying you must have 1 XLM. So whichever way you see it, it basically means the same thing. So yeah, let's go to sub entries. So we didn't talk about sub entries before, so it's more like a new concept in this video. But looking at sub entries, right? It's sub entries are like a subset of base reserves, accounts rather. So when you look at sub entries, they store accounts data, right? So they're like each of those little data that exists in accounts. So an account can have a lot of sub-entries, and basically you have a total of 1,000, just 1,000. So sub-entries are more like those um pieces of an account. You can look at it that way. So they store accounts data. So they store accounts data, and every account increase an account balance. Every account sub-entries increase an account balance by 0.5 XLM. So like I said, they're like chunks of an account. So if you look at it from that perspective, then you know that every sub-entry holds data, and every sub-entry holds an account balance, right? A minimum balance also. Holds a minimum balance also, just like 0.5 that we already talk about for base reserves. So, and one thing to know also is that only 1,000 sub-entries are possible for an account, according to, yes, how we have it here. Only 1,000 sub-entries are possible for an account. So it means that like they're just like a lot of sub-entries that makes up an account, right? So, and then possible sub-entries for an account are trust lines, offers, additional signatures, and data entry. So we'll talk about all of this also in later videos because they require their own lengthy discussion or elaboration. So we'll come to this when we come back to accounts in another section of this series. So yeah, let's moving on from that. We already just wanting to just understand that the important information here is that sub-entries store accounts data, and each account sub-entries increases an account balance by 0.5 XLM. And an account can have a maximum of 1,000 sub-entries, a maximum of 1,000 sub-entries. So if you say that an account can have a maximum of 1,000 sub-entries, that's the limit that it can exist in Stellar currently. So now let's go to the third one. Let's look at the third component, the third data structure we have in Stellar. We have the assets, right? Now looking at the assets, what are assets? We already mentioned assets in the first video when we talked about why do we have Stellar and what does it do for us. Excuse me, I'm going by that. We have certain things that we can talk about assets, and we talk about, and when we look at the asset is that they can mean a lot of things, right? So an asset can be a cryptocurrency, it can be a fiat currency, it can be other token of value, it can be pool shares, it can be bonds or equity, just like it's listed here. So you can have an asset in different form, and an asset could also be your own time. Let me even add that here. So it could be a custom asset, for example, your time. Your time. Your time is also an asset. So you can map it as an asset. So an asset in Stellar can mean a lot of things. It can mean your time, it can mean bonds and equities, pool shares, tokens. You can look at tokens as NFT, other form of tokens as NFTs, fiat currencies, cryptocurrencies, all of those things. And when we talk about asset also, asset have two identifying characteristics. So there are two things that defines an asset in Stellar. The first thing that defines an asset in Stellar is the code of the asset. So when you have an asset in Stellar, right, just say we have in other blockchains, basically, you have a code for it. So for instance, an asset, let's say a cryptocurrency now, let's use a cryptocurrency as an asset or any of these asset forms, right? But let's pick a cryptocurrency. You know, a cryptocurrency like, let's say BTC or XLM, for instance, using the XLM, it has a code. The code of Lumen is what? XLM. In that regard. Or you could have an asset like USDT, for instance. If you have USDT basically means the code for a particular asset that exists on the blockchain. So now, on Stellar, for instance, in Stellar now, basically, you have an asset code that identifies an asset, and then you have the issue of that asset, or the issue of the asset, yeah. So you have the asset code, the first thing you have, and then you have the issuer of the assets. So this should be the issuer of the assets. That's the unique code, not the issue. So we have the asset code and the issuer of the asset. In what sense? Just like I explained about the asset code, right? You have a code for the asset, and the next thing you need to have is the issuer of the asset. Who is the person that is issuing this asset or that owns this asset, or that is deploying this asset? That's a better term to use. So when you look at it that way, you know that whoever deploys this asset and the code of the asset makes it different, right? So it makes it unique. So the issuer in this case is the unique code of the asset, basically. So it's the unique code of the asset. So you can look at it that way. And like I use using the example of USDT again, you can have multiple issues of USDT. Like what I mean by that. So let's say a company A deploys an asset called USDT, Another company B deploys another asset called USDT. What differentiates these two assets is the issue of the asset, right? So you can look at it that what differentiates those two. So that's why it's the unique code of the asset. Probably let me remove this. Don't need this. So it's the unique code of the asset that is being deployed or that exists on Stellar. So what does it do? It just helps to check against duplicates, right? That's why it has to be unique. So it does the same way I explained company A and company B having the same asset code, right? But different issuers. So the fact that the company that issued that token or the asset in this case are two different companies. So that makes it unique, even though the assets have the same representation on chain, right? But the issuer of the assets make it a different asset for every amount, for every number of companies that deploy the same name of an asset called USDT. I hope that clarifies it. So yeah, so asset have two identifying characteristics, the asset code and the issuer, and it helps to prevent duplicates on the Stellar network. Using the analogy of company A and company B, it kind of explains it a bit in a good way, right? Because you can have many companies. You can have company A, B, C, D, E, F deploying the same USDT, but what differentiates them is the fact that they are different companies. The issuer of that asset is company A, another asset is company B, another asset is company C, another asset is owned by company D, another asset is owned by company E. So because of the fact that all the issuers are different, it makes it unique on the Stellar blockchain. So that's that. So now let's look at the last one, the last data structure, which is contract, smart contract. Now, prior to writing smart contract on the network, it's good to have an idea of this, right? So let's look at smart contract and talk about it before we dive into smart contract writing. So what are smart contracts? Smart contracts, basically, giving an idea in a general term, are just logic, they are code logic that are meant to execute or perform certain actions. So it's just a program set of code, right, that is used to perform certain actions on the blockchain. So in this case, they are contracts, right? They are binding contracts, they are code, they are laws that guides certain actions and certain principles, certain rules that give certain rules to certain actions on the blockchain. So in this case, now you can look at them as a program set of executable code, right? That and states that can be invoked or used on the Stellar network. Now, looking at it from a general perspective, it's just code, right? That you deploy to a blockchain that gets executed and perform a certain action. And we call those actions transactions on the blockchain. So those are smart contracts. That is what we refer to as smart contracts. So they are programmable, they are logic, and that is what we have as smart contracts. So looking at it as understanding from that point of view that smart contracts are just code, right? They are programs, they're computer programs that you need to execute on the blockchain. So let's look at the component of the smart contract in Stellar. And smart contract with respect to Stellar also means that you have a set of code that you've written, and then you are deploying that code to be run on the Stellar network, right? To get executed, to perform certain actions, to do certain things that you have predefined in the contract, right? And they are binding, like I said already. So they are binding, and that means they need to they enforce whatever logic they are meant to enforce. So now, coming from that understanding, let's go to the components of the Stellar smart contract. Now, there are three components basically to understand about smart contract in Stellar. The first one is the WASM, also known as the web assembly. So WASM is web, in this case, and assembly. Assembly. Yes. So WASM basically means web assembly, right? And that's the first component of smart contract in Stellar. And so what is web assembly? So this is how it works. So when you have a contract, say I have a contract here, I have a contract with code. I'm going to call this, let's say this is my contract. Let me change the color to a neutral color. So I have this contract and I have code in it. Say I have a function and I call the function or say I have a contract. It's like this. And this is just an example. It is not the structure of a contract. And then I have a function in the contract, function one, and then I have another function in the contract called function two. Right. So let's say this is a contract. The functions contain logic. Function one contains logic, function two contains logic. What happens here is that when I deploy this contract, right, and when I it has been written by me as a developer in this case. And what I need to do to convert to WASM is that I need to compile this contract. So the idea here is that this contract has been written, it needs to get compiled. That's the first thing that needs to happen. So I need to compile this contract down. That's the next step. I need to compile this into a format that is understood by the Stellar network. So what that means is that I need to compile it down. Now, let me call this the WASM code. And change the color from the WASM code. Let's call it a nice orange color. It's going to get smaller, right? Because it's going to reduce the size. So let's call this the WASM code, right? This is the code. This basically gets compiled, right? It gets compiled into this. So let me just add this place. So it gets compiled into WASM. So that's basically what happens. So the code gets compiled into, yes, let me do it this way. So it gets compiled into from this contract that we have up here, right? So we have a contract here. So we have a contract, and the contract gets compiled into the WASM. That's WebAssembly executable. So this is an executable file. WASM is an executable file, and then you install it. So let me call it WASM and add executable. So executable in the sense that you can run this program. I run it as a program. So an executable program is something you can run. Probably, for as an instance, you have a browser that probably you use to watch this video right now. A browser is an executable program, right? That is why you're able to run it on any device, any operating system. It's the same flow for the code you are running on Stellar, right? So this program, this smart contract gets compiled into this WASM executable. And the WASM executable is what gets installed on the network. So what does that mean? We have this. After we understand that it gets compiled down into this, we need to link this to the network. So let me use the arrow to indicate something. So it's saying that the arrow comes in this form and is installed. This gets installed on the network. So what we're saying now is that this needs to be installed on the Stellar network. So saying this is the Stellar network now, let's use a green to indicate the Stellar network because it is online, right, and it's active. So now let's say this is the Stellar network, and let's make it a bit bigger because yes, it's a network. So exactly. So now this basically is the Stellar network, right, for reference, and this contract gets compiled into this, and this gets deployed. Okay, this is a basic analogy, right? But I feel like he explains it well. It gets installed into the network. Yes. So this is what we have. So this gets compiled to WASM executable as an executable file, and WASM gets it installed onto the network. And that's basically what you understand, what you need to understand for now. There are other concepts here. For instance, let me just add a bit of things. So when you deploy this to the network, it's not just everything that happens, right? This is a binary executable. The WASM is a binary executable. And I think I need to add that too. So it's an executable file. It's a binary file, binary executable file that gets installed onto the network. And when you install this onto the network, a slot is created for this binary file, right? So let me add that. Let me call it a slot and reduce the size. So let's say this is a slot for this contract, right? So let me call it contract 1 for reference. So this is contract 1. So let me reduce the size a bit, call it, no. So this is contract 1, and contract 1 has a storage space is created for the contract 1 on the network, right? So we call this the contract data. So contract 1 data. That's what it's called. So this exists. This, when it is installed on the Stellar network, a space is created for it on the network and it's stored there. And that contract data is created, right? This data, this storage here, to store the value of, or to store whatever is coming from, to store this executable binary, right? That's basically what it does. So it stores it and it stores an hash of it. So we don't want to go into hashes yet, but basically what it does is that it stores the result of this executable binary, because you are installing it into the network. So you are basically installing data, right? You are compiling, you have a data that is coming from this binary executable. It has a size. So that size is created for this contract on the Stellar network. and that is what we have here. So this is more like a basic explanation. I feel like this covers most of what you need to know about WASM for now, right? But this is for if you are just new to Stellar, basically. So and we have all of this. We have the contract data, we have WASM, we have the contract one, we have the storage space, right? So this is more like a high level overview, right? So yeah, so and whenever this one thing to also notice is that when you want to install this, a VM is created for you. It's more like a sandbox environment. So a VM is a sandbox environment whereby you run your program. In this case, the program you are running is this binary executable that is stored on the network, right? So whenever you want to execute this contract now, for any reason, what you need to do is, let me get an arrow to explain that now. So you want to execute, say you want to execute this smart contract, right? What you need to do is to then retrieve the smart contract. Okay, so let me just explain this stuff. So that started, you need to retrieve the code, the data, right? Retrieve the data. You can call it the bytecode also. So let me call it the bytecode. And call it the bytecode. So you retrieve the data or the bytecode in this sense. So you retrieve that, and once you retrieve that from this place, it gets sent to a VM, right? So when you want to, like, basically everything that I'm drawing outside here still happens within the network, right? So I'm just using this as reference to explain it outside of this, so it won't get clogged. So then we have this sent to a VM. A VM in this case is a virtual machine, and a virtual machine, I'm going to represent that with another color. Let's say it's a purple color. So this, let's say this is a VM, right? A VM is a sandbox environment. So a sandbox. So the sandbox environment, let's just call it a sandbox environment. So that is what we refer to as a VM. So the data gets sent, you retrieve it from the storage, right? From the contract, you receive from the storage that was created for that contract, then you send it into this VM to get executed, right? And that is where everything gets run, and and once we are done, it gets exited. So this data, this diagram is important because we are still going to make use of it when we talk about storage, right? Because we've mentioned a lot of things. We've talked about the WASM, which is this. We talked about the contrast instance that gets installed, and then we talked about the storage also that was created for that contract. So I feel like this explained a lot of everything that we still talk about for the contract instance and storage, but let's go there and talk about it also. So we understand now that the flow from contract to WASM to Stellar Network to having bits get executed in a VM, right? Like VM is a secure sandbox, so it's very secure in this sense. And so it runs the bytecode, right? It runs the bytecode, and this VM runs the bytecode. So let me add one more text here to make it clearer. So runs bytecode. So this runs the bytecode, right? So the VM runs the bytecode. It's good to have an idea of that. So the VM runs the bytecode basically. So that is what we have here, right? So we have this, the VM runs the bytecode, and yeah, so that's basically what we have for this. Oh, I've messed up this. Okay, yes. So we have the bytecode, we have all of this. I think this is explanatory, right? This is clear enough. So now let's go to contract instance and talk about contract instance. So we've already spoken about the WASM. So now let's look at contract instance. So when we've done all of these things, right? What you need to understand about contract instance is that for every time you are deploying a contract, right? They are deploying a contract with the same bytecode. A new contract is deployed, even though this same bytecode, right? A new contract is always deployed. So what we refer to as a contract instance is an instance of that same contract that has the same bytecode. In the same bytecode in this sense is I can have the same for contract multiple times in this sense, and I can have contract one with the same function one and function two, and it still gets compiled to this. But when it is creating a place for it on the blockchain, on the Stellar network, a new storage slot is created for it. So basically what it means is that this is contract one with function one and two, right? If I create another function, let me duplicate this, and I duplicate this function here. Okay, this is probably going to get messy. So let's say this is contract two, right? It has the same binary and everything, right? I will just target contract two because it's an instance. So It has the same binary and everything. So what I mean by the instance in this sense is that it has the same instance as the first. It has a different instance as the first than the first one, right? Even though it's the same bytecode. But what gets created here, just like contract one gets created, is another instance of contract two, right? Even though it has the same bytecode. So in this case, this is basically what we refer to as contract instances. So then, I think that's the idea. That's a whole lot of things we need to understand. So now let's come to contract storage, right? So what do we refer to as storage? We've already mentioned that storage gets created for your contract, right? When you deploy your contract, storage gets created for it. And using this simple diagram to understand it as basic and as it is, it tends to like explain the storage side of it also, but it doesn't really give justice to the entire storage implementation of what happens within the network, right? But it gives a clearer picture to an extent. So remember from when we were talking about lumens, right? That we mentioned that you pay rent for smart contracts, right? So smart contracts pay rent on the network, and the rent they pay depends on the size of the data they are storing and the duration of that data. And the duration of the data depends on all of this storage. So for storage, we have three types of storage basically. So let me add that here. So we have it as let me change this to bullets. So we have the temporary, we have the inst. Okay, let me not call the instant yet. We have the persistent, and then we have the instant. Yes, so that the three. And remember from when I was explaining these three storage types the other time, I said that this basically are the two we consider, right? And the instance is basically it's more like an abstraction of the persistent. It's similar to the persistent in the way it works, but in a different way. So it works with storage instances, contract instances. That's the difference. But for temporary storage, when we talk about contract storage, temporary storage, and instant storage. So for temporary storage, it simply means you have, let me reduce the size. Sorry. Okay, so for temporary storage, it simply refers to what you store that are temporary, like from the contract. So they are basically the name, what the name implies, and the literal term as temporary storage. It simply means what you store on the blockchain that is temporal, that is not persistent, right? It's just meant to get executed, and it has a lifetime, right? And the lifetime, once the lifetime is done, you stop paying for that particular execution. So it has a lifetime, right? And you get, so basically what happens is that when you store data on the blockchain, for every entry that you have um for every entry, right? So basically you are paying for that entry. That's what we refer to as you're paying rent, right? But now the rent that you pay depends on this lifetime, right? And some of them, most things you pay for are storage, temporary storage, you pay for persistent or for instance. So like I said, temporary storage in this sense means you are paying for something that exists temporarily on the blockchain. Past persistent means you are paying for something that has a longer lifetime, right? It exists for a longer time. And also, what you need to understand is that temporary is a lot cheaper than persistent because this exists for a longer time, right? And for the lifetime of this persistent storage, whatever data you store in storage, similar to what we have here and here, and you store in storage that exists for a longer time, right? You need to keep paying for it. So, but for temporary storage, they are cheap. It's the cheapest actually, and it's permanently it's temporal. But once you delete data from it, it's permanently deleted. There's no way to recover those data when their lifetime gets when the lifetime is over, the lifetime of whatever data you store in them is over. But for instance, right, for instance, it simply refers to as, you can see that it's an instance here also. So it's making reference to the contract instance. So for contract storage instance is when you understand persistent storage, simply that persistent storage are those data entries. They're basically data that you store on the blockchain that remain for a long period of time, right? So for instance, an instance of persistent storage are balance. Your balance on the network is an example of persistent storage. They stay there for a long time. They are not removed. But for temporary storage, they can be functions or value or temporary data that you store or that you get called from a smart contract. So for the lifetime of that function call or for that particular value of for that entity, it gets stored in temporary storage. but the moment you are done with it, it gets deleted. But for persistent storage, an example, like I said, is a balance. Your balance remains for the lifetime of your account on the blockchain. So we have all of those things as persistent storage. Then we have the instant storage as well. In this case, we have the instant storage, and the instant storage is similar to the persistent storage, right? But for the major difference is that it works for contract instance. For smart contract, so we have all of those things for smart contract, right? So if you understand all of these things, they're basically just this. This gets created, gets very, very easy to understand if you look at it from this diagram. And I feel like this explains everything you need to know about the stellar data structures. So yeah, this covers the entire stellar data structures. I hope you've learned something from this. I hope this explains a lot more about the stellar data structures we have in Stellar now, so that when we start moving into creating smart contract or working with smart contract, you already understand that we've mentioned this, so it will be easy to flow from there. So thank you very much for watching this video, and see you in the next tutorial episode.